There are some more questions that were emailed, so I'm going to cover them in this video, starting with number 3, parts 3, 5, and 6 for part A. So when we look at this one, we are doing f times g for part 3. So f times g would mean that we're multiplying the f function times the g function. So notice that there are some things that can reduce here. 2x and 4x can reduce. That would just leave a 2 in the bottom. So this is 5 over 2 times x minus 7. The domain for multiplication is the restrictions from both, or the intersection of the restrictions from both, which would be 7 and 0. So x cannot be 0 and 7. So there's the multiplication. For part 5, we're supposed to be doing f composed with g. So that means we're going to take the f function as an outer shell and we're going to plug the g function in. The f function is 2 times x, so that'll be a blank, over x minus 7, so that'd be blank minus 7. The g function is 5 over 4x. Go ahead and clean up a little bit on the top. That would be 10 over 4x over 5 over 4x minus 7. If we multiply everything on top and bottom by 4x, that will cancel out those denominators. So this just becomes 10 over 5 minus 28x. So there's f of g. And your domain here is the two things you have to consider. What was the restriction for g of x, which was 0, because that's the part you plugged in, and then what's the restriction at the end? So this would be, set that equal to 0, add the 28x over, divide by 28. So x cannot equal 5/28, and x cannot equal the 0 from the part that was the interior function. For g of f of x, so I'm going to do that one over here. This time we let g be the outside function, so 5 over 4 times blank, and we plug in the f as the inside. So this would be, if I reduce that a little bit, that'd be 5 over 8x, x minus 7, and then multiply top and bottom both by x minus 7 to get rid of the denominator in the bottom. So that would be 5x minus 35 if we distributed over just 8x, or you could just have 5 parentheses x minus 7 over 8x. That would be okay as well. The domain restriction is, what was the restriction of f of x, which was 7, because there's f of x, and what's the restriction at the end, which looks like it would just be 0. So this one would have a restriction of 0 and 7. Okay. Another question that was posed was 7b. Finding the zeros of the given function. This is using, if this is not factorable, which this one does not, you can pull an x squared out of the first pair, but you can't pull anything out of the second pair. So you're not going to get matching binomials there. So we need to use the c over d method. C is always the constant, or excuse me, yeah, the constant, and d is always the leading coefficient. So factors of c are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Factors of 1 is just plus or minus 1. So my list of possibilities for rational zeros would be 1, 3, 5, and 15, where all of them are plus or minus. Just to save some room, I put my plus or minus out front instead of on each and every one with the parentheses there. So I need to try synthetic division. So we'll try positive 1 first using our coefficients. Pull down a 1, multiply, 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 and we do not get 0. Try negative 1. Pull down the 1, multiply, multiply, do not get 0. Positive 1 was closer, so I'm going to try positive 3 next. Multiply, multiply, and there it is. So positive 3 is definitely a solution. We can write that here. This is going to be now quadratic because when it goes from x cubed and you do synthetic division by a power of x to the first, you then get 1 power less. So this is x squared plus 2x minus 5 equals 0. And we would want to try to see if that factors. It does not look like it does. So we would do quadratic formula. So x equals negative b plus or minus square root. B squared root would be 4 minus 4ac all over 2a. So that's going to be negative 2 plus or minus the square root of, that is positive 20 plus 4, that's 24 all over 2. So I can reduce that down a little bit. I'm going to write it over here so I can show my work. 24 is divisible by 4. Square root of 4 is 2, but there would still be a 6 left inside. So this looks like negative 1 plus or minus the square root of 6 if we reduce the 2's out. So that's all 3 of my solutions. 1 rational solution and 2 irrational solutions, but all of them are real. None of them are imaginary. Okay. And then I was asked for number 12 as well. So we're going to be doing the domain, x-intercepts, y-intercepts, holes, vertical asymptotes, horizontal asymptotes, and obliques for the 3 problems below. So we'll start off with A part. You need to factor the denominator to figure out what your domain and possible vertical asymptotes can be. So that's x plus 5, x minus 2. So nothing's going to cancel. So my domain, besides domain is done before you cancel anyways. So domain is x cannot equal negative 5 or 2. My x-intercepts have to do with whether or not I have any x's on top, and I do. That would be equal to 0 when we have a negative 2, so that'd be negative 2 comma 0. You find the y-intercepts. Sorry, this should not have a, b, c. This is all a. You should find the y-intercept by plugging in 0 for all of the x's, so that would be a positive 2 on top and a negative 10 on bottom, so that would reduce down to negative 1/5. Holes only if something canceled, so we have none. Vertical asymptote, anything that is in the denominator that does not reduce out is a vertical asymptote. So x equals negative 5, x equals 2. Remember, vertical asymptotes are equations, not ordered pairs. Horizontal versus oblique has to do with long division. You can only have one, not both. So think about x squared plus 3x minus 10 going into x plus 2. X squared cannot go into that at all, so this is going to be horizontal because anytime you just get a number on top, it's horizontal, and it's just y equals 0. Okay, let's look at B. B, we have some factoring to do. I'm actually going to do it right here. I can pull an x out of the top. That would be x squared plus x minus 2. The bottom is an x plus 1, x minus 1. That would give us x times x plus 2, x minus 1, because that also factors. So we're going to get a cancellation on this one of the x minus 1s. For domain, domain is still anything that was in the original denominator, so x cannot equal negative 1 or 1, regardless of whether or not those are vertical asymptotes or holes. They're both issues for the domain. The x-intercepts would be anything left over on top that has an x. So we have 2 different x-intercepts, x equals 0 and x plus 2 equals 0. So x equals 0 would be 0, 0. X plus 2 equals 0 would give me a negative 2 comma 0. So there's 2 different x-intercepts. The y-intercept is found by plugging in 0 for all the x's. That makes the whole top 0 over negative 1. So that's just going to be 0, 0. Vertical asymptote, oh sorry, holes, skipped one. The hole is found where this cancels, so x minus 1 equals 0, so it happens at positive 1, and then we have to figure out what that value is going to be. So these were x-intercepts. This is the hole. So we plug 1 into what's left. So 1 times 1 plus 2 over 1 plus 1. That's 3 times 1, which would just be 3 over 2. So this is 3/2. Vertical asymptote, that would be anything still in the bottom. That's going to be x plus 1 equals 0. So that's x equals -1. Remember, that's an equation. And then when we try to do long division on this one, we actually are able to divide. And this is going to be a case where we get an actual x on top, because x squared goes into x cubed x times, and we multiply that. So that's x cubed minus x. Change our signs. That gives me x squared and then minus 1x. X squared goes into itself plus 1 time. And we know we're done there because we've reached our constant, but this means we have no horizontal because this time we got an x on top. But our oblique would be y equals x plus 1. It's a line. Now you're not going to have to graph any obliques, but that's how you would find it. And then I don't have enough room, I don't think, to do c. We'll see. Pull out an x on top. That would be, actually we can pull out more than that. We can pull out a 3x. So that would be 2x minus 3 on top. On bottom, this factors into 2x plus 3 and 2x minus 3. So the 2x minus 3s are going to cancel. So the domain is going to be what would make 2x plus 3 and 2x minus 3 equal 0. You subtract 3 and divide by 2, so x cannot equal -3/2. On this one, you would add 3 and divide by 2, so +3/2. The x-intercepts, there's just one. There's a 3x left on top, so that means it's at 0, 0, because 3x equal to 0 would just be 0. Y-intercept, again, everything on top is 0 because it's all x's, so this will be 0, 0. There is a hole this time because something canceled out. It happened at, remember, +3/2, this part right here. If you plug 3/2 back into what's left, that would be 3 times 3/2 over 2 times 3/2 plus 3. So that's a 6 on the bottom and a 9 over 2 on top. Think that a 6 over 1. So we can multiply top and bottom by the reciprocal to get just a single fraction. That would be 9 over 12, which reduces down to, I'm going to make some lines to separate these, to 3 over 4. Hang on just one second. The PDF likes to crash when I do a lot of problems. So let me reopen it. Okay. All right, so 3/4. For vertical asymptote, there is this -3/2 that comes from this parentheses that's still down here in the bottom. So x equals -3/2. Horizontal versus oblique, we need to do our long division. So 4x squared minus 9 into 6x squared minus 9x. So 4x squared turning into 6x squared. The problem with these is that when it's 4 does not multiply to make 6. So what we want is we want the 4 to cancel out when we multiply. So you want a 4 on the bottom so that 4 divided by 4 would be 1. You want the top, though, to turn out to be the number inside, so that's going to be a 6. And x squared is already x squared. So it's going to be 6/4, so y equals 6/4 with no x, so that's going to be a horizontal asymptote, and we would reduce that down to 3/2. So y equals 3/2, and the oblique is none. So that is how you find all of the pieces of information for each one of those.